So one final application of double integrals is probability distributions, and these can show up in physical and non-physical phenomena. So one example of a physical phenomena is a dartboard. So if someone throws a dart, the probability that they've thrown it is 1. Probability that they land at any given point is given by some function. Depends on the person's skill and maybe if there's wind in the building they're trying to throw it in and anything else. If you integrate over the whole region, and if it's me, you might have to take a bigger region than just the dartboard. I may throw it and have it land here or here. But eventually, if they take a big enough region, I can get everything, every point whose probability is non-zero. If I integrate over all of that, the answer should be 1. So that's one feature of probability distributions. 1 is 100%. Some non-physical examples are like weather forecasting. They do a bunch of calculations and tell you the probability of precipitation tomorrow is 40%, or maybe in Seattle they tell you it's 80%. Anything that requires predicting, like the stock market, fantasy football, anything that has an uncertain outcome, you can use a probability distribution to model it. So the last 2 videos I haven't done an example because those were calculations you did in Math 126, and so as long as you know the formulas, you should be able to do the calculations. Here we'll do an example since this is new. This is actually a question from another professor's midterm. Joint density function, this is another word for probability distribution. Some people call it a probability density. Those mean the same thing. Random variables just means not certain. There's some other technical things about random variables too, but we don't need to worry about that here. All we need to know is that this is a probability distribution. It's 0 if both x and y are not non-negative, so that's great. So we only need to integrate in the first quadrant. And they want to find the constant c. So this isn't given to you. C scales the function. So to know how big c is, all I need to know is how big the total function is. Well, I know, remember I said the double integral over the whole region had to be 1. All right, in this case, I know that x and y are both greater than or equal to 0, so I'm going to integrate just from 0 to infinity. These are improper integrals, which is fine. So c e to the negative x, e to the negative y over 2. I think it's going to be easier. It doesn't matter in this case, but I think it's going to be easier if I integrate with respect to x first. That way I delay getting fractions in my answer or in my calculations. Okay, so I know the answer is going to be 1, so I'll just perform the integral on the left side, set it equal to 1, and hopefully I'll be able to solve for c. Integral, so everything's constant except e to the negative x. So I get negative c e to the negative x, e to the negative y over 2. That's going from 0 to infinity. Technically, there's a limit here. If you're comfortable with improper integrals, you don't have to write the limit. You can just think as you're taking the limit as x goes to infinity of e to the negative x. So that's 0. So the limit is going to be 0. And then you're taking x is 0, so that's e to the negative 0 is 1. And then there was a minus sign there. So minus a minus is a plus c e to the negative y over 2 dy. I shouldn't write equals there because I have equations going on here. No equals down the left if I am already writing equations. That's if you add the same thing to both sides. It's not equal to the previous line. Okay, integrating this, I get, let's see, oh, I'm integrating, so no more integral sign. Negative 2c e to the negative y over 2, going from 0 to infinity, and that's still, we know the answer is going to be 1. Taking the limit as y goes to infinity, that's still e to the negative really big number, so the limit is 0, and then we're subtracting a negative, so that's positive again. 2c e to the negative 0 is 1 equals 1. Okay, so that means c is 1/2. So I've solved the first part using the principle that the integral over the whole region where the probability function is non-negative is 1. Okay, now we want to know the probability that the sum of x and y is less than or equal to 1. And there's this weird convention, don't do this anywhere else, but there's this weird convention in probability where they call the probability variables by their capital letters, and then when you talk about values at a point and other things, we use lowercase the same letter. But everywhere else, do not use the capital and lowercase letters interchangeably. They can represent completely different variables. Okay, so this might be useful, right? If you are thinking about the weather and you only want to go to the beach if it's sunny and the weather's above 70 degrees, then that would be like a joint probability of two things. Or maybe you want to go if it's sunny and over 70 degrees or cloudy and over 80 degrees. Now this is actually more like this, right? These things add up to a maximum or a minimum. Okay, what does that mean? X plus y is less than or equal to 1. Well, that's this line, so they add up to 1. So here's 1, 1, and then everything adding up to 1 is a line. If I kind of think of the line conceptually this way, I don't need to think about slope or anything, or intercepts. Okay, and then less than or equal to 1 must be here. We've already said we're in the first quadrant from before, so that's good. And now this is the region I'm integrating over. So I need to integrate my probability function. C is now 1/2, e to the negative x, e to the negative y over 2. And then, again, easier to integrate with respect to x first. So y is going to be on the outside. So y goes from 0 to 1. And then for each value of y, x goes from 0 to this curve. This is x plus y equals 1. So x equals 1 minus y. 1 minus y there. Okay, then I just perform this integral. Integral from 0 to 1. 1/2, there's a negative, e to the negative x, e to the negative y over 2. We're plugging in 0 and 1 minus y, dy. Let's write y over 2 smaller so it's clear that it's in the exponent. Okay, then this is the integral from 0 to 1, putting in 1 minus y for x. Okay, so negative 1/2 e to the negative 1 minus y is y minus 1, e to the negative y over 2, and then minus a negative is a plus, e to the negative 0 is 1, e to the negative y over 2, dy. Let's just clean this up a little bit before we integrate again. So this is negative 1/2 e to the, let's add the exponents. So this is y over 2 minus 1 plus 1/2 e to the negative y over 2. Integrating with respect to y. All right. Now, integral from 0 to 1. No, I'm going to integrate. So no more integral. Then we need a chain rule. Reverse chain rule. So this is going to be negative, no more 1/2, e to the y over 2 minus 1. I think that's right. Take the derivative, make sure you get back to there. Here we get a negative, no more 1/2 either, e to the negative y over 2. I believe that's right. Okay, and now y is going from 0 to 1. So we put in 1 for y. That's negative e to the negative 1/2 minus e to the negative 1/2. And then minus and negative, so these will all be pluses. Putting in 0 for y, e to the negative 1 plus 1. So for a total of 1 over e minus 2 over root e plus 1. And whatever that number is. So this is about, here we can estimate it, or you can use a calculator and get it. That's about a third. I don't know, root of 2.7 is 1 point something. So this is minus, 1.5 maybe, and then plus 1. That's, okay, that's probably smaller than 1.5. Anyways, use a calculator to get that exactly, and you can figure out, hopefully it's a number between 0 and 1, otherwise we made a mistake, what the probability of this is. And as I said, you can use that to solve things like what the probability is that you would want to go to the beach is if it's based on two different things.